Hello friends, in continuing with our crystallographic texture discussion, today we will see few texture components, especially in different type of material, for example body centered cubic and face centered cubic. Okay. Mainly it will be as an example it will be steels and aluminum alloys, okay, and we will try to see what are the different texture components and means how it will look in the way we were looking at texture representation in terms of pole figure and ODF, okay, how the components are located in the stereographic space or Euler space. Okay, so if you see the dependence, the texture depends on the material, of course, in different type of material depending upon crystal structure, purity. Sometime alloying element also changes a lot the material properties and therefore the development of texture. Stacking fault energy, so this SFE is basically stacking fault energy of the material, okay, and of course what is the prior deformation condition which affects the texture development. In general, if you want to see a complete picture, okay, that what different type of texture components are there in materials. For example, in this case it is steel, so BCC phase and FCC phase for both it is shown here, okay. So if you see BCC phase, there are some fibers are written here, okay. So fiber means that if you have a for example, it is already given here, okay. So in this case my 110 direction is parallel to rolling direction, but we are not specifying the plane, okay. So whenever you have a fiber, that means any plane whose 110 direction is parallel to rolling direction, okay. So it can be a 001 plane whose 110 direction can be parallel to RD, okay, or you can have another 110 type of plane, or you can have a 111 plane whose 110 direction in parallel to RD. So we are not specifying the plane here, that means we are taking any plane, okay, and when you have a plane, if it contains the 110 direction, that direction can be made parallel to RD, but there is no specification for plane, okay. So if you have that condition, for example the planes are written here, so you can have 001 plane, a 112 plane or a 111 plane, okay. But for all the HKL UVW, this texture component, the direction will remain same, okay. So if you have this kind of condition, then we call it as a 110 fiber, okay, which is in case of BCC material, that is a alpha fiber. There is another fiber, very important fiber, which is called gamma fiber. In this case the 111 direction is parallel to ND, okay. So again you can see the component, it is 111 with 110, another 111 and with 112. That means right now we are not specifying the direction in this case. So it can be either plane or direction. In case of cubic material, the direction and the direction of the normal to a plane and the direction of the same index will always be parallel, okay. So it does not matter whether we are differing in terms of plane or direction, okay. So like that there are other components also shown here, different fiber names and their fiber axis and the relevant component, okay. In terms of pole figure and Euler space, if you want to see that how they are arranged, okay. So the one which I was telling you about, the gamma fiber, okay, that is located somewhere here, okay, which is around 45 degree in the phi 2 angle is 45 degree, another I think 45 degree is for phi, okay, and a continuous fiber in the phi 1 direction, it is continuous fiber, okay. So it starts from 111 110, then 111 121, then 111 011 and so on. So a complete fiber is there in the Euler space, and there are other fibers also mentioned on the Euler space, okay, that what will be there Euler angles. Okay. The same thing can be shown on a pole figure also. Again you have alpha fiber which is shown with a square notation, then beta fiber with a triangle and gamma fiber with a circle. Okay. So, their position is marked here. For example, for gamma fiber the positions are marked here, here, okay, and some locations within. Okay. So, all these positions are marked. Similarly, for beta fiber and gamma fiber. Okay. So, all this texture component can be shown on the either pole figure or Euler space also, or in terms of HKL UVW value which we have seen in the previous slide. One of the most important section when we talk about BCC material and in terms of their formability of the steel material. Okay. So, if you want formability, then one of the most important section to look from all the slices of the ODF is where the phi 2 is 45 degree section. Okay. And if you do that, you can see that the phi 1 is here from 0 to 90, phi is there from 0 to 90, and phi 2 is equal to 45 degree here, in which you can see both the alpha fiber, okay, the gamma fiber, okay, another epsilon fiber is there, and you have a gauze texture. Already we have seen the gauze texture in terms of pole figure, that how the pole figure will look for a gauze texture, okay, and in terms of HKL UVW this will be the texture component for gauze. Okay. So, again for formability this gamma fiber is very important in case of in steels. Okay. Now, what different type of processing gives you texture? Okay. So, it is the effect of, you can say, processing on texture. Okay. So, hot rolling, I am not talking about microstructure right now. Okay. So, you have very strong rolling texture, okay, strong rolling texture with alpha and gamma fiber, okay, and also some shear texture components will be there in the material. If you are doing cold rolling in steel, okay, then you will have in terms of texture increase of alpha and gamma fiber orientation, okay, and so these will be the components for both of these, okay, and if rolling is less than 75%, you will have alpha and gamma like this. If rolling degree is more than 75 degree, then you will have this particular texture component and also again alpha and gamma fiber. So, basically sharpness of alpha and gamma increase, surface has increase of alpha and gamma fiber orientation, okay, but much stronger 001 110 texture component also. Suppose if after cold rolling you are doing a recrystallization, static recrystallization, okay, then there is a strong decrease of the alpha fiber orientation, okay, and the increasing density of gauze orientation with increasing amount of shear bend, sharp rolling texture component lead to sharp recrystallization texture component. So, if you have a sharp rolling component like this, that will lead to a strong recrystallization texture component in the material. Okay. So, these are the different type of texture which will develop due to different type of processing. Okay. So, you can do hot rolling, then you will have certain texture components. You can do cold rolling, okay, again you will have certain then that case we also call it as deformation texture. And after cold rolling you can do a recrystallization process, then you will have effect of this texture component which were generated during rolling onto the recrystallization texture component. Okay. Now, these are the texture components for face centered cubic materials. Okay. So, you have brass, S, copper, shear component, gauze, cube, okay, and some more are there. So, the first these ones are a deformation texture component which arise due to the deformation process, and these texture components are there when you do some static recrystallization of the deformed material. Okay. So, deformed material leads to recrystallization. So, there will be some change in the texture component. So, now you will have gauze, cube, rotated cube. Okay, rotated cube means if you put cube, you can rotate it in any of through any of the axis. Okay, so either RD1, RD2, ND1, ND2 and so on. Okay, and these are the Euler angles for all the texture components. Okay, and as you can maybe able to understand that cube should always have 0 0 0 as I had already told you, because in case of cube the unit cell is already aligned with the our sample geometry. Okay. In case of Gauss it is just a rotation of 45 degree on one angle. Okay. So, that is what you can see here. Okay. And instead of theta I will put the capital phi here. Okay. That is what we discussed in the previous lecture. Again this same FCC texture component we can look in the pole figure. Okay. And the pole figure will look something like this. So, this is a 1 pole figure. Okay. In which case you see a typical shape like this. Okay. With some intensities at the RD near RD. Okay. So, this is the 1 pole figure. Okay. So, 1 pole figure, and all the components which are visible here are shown here. So, the triangle is copper. Okay. So, where the copper components will be there. Okay. Then you have S1 S has 3 different variants. Okay. Then you have brass, which is shown by a yellow square. Okay. So, these are shown here. Okay. All the brass components. Then you have Gauss component. Okay, which is shown here. Okay. So, in a 1 pole figure this is how all the different texture component will be distributed. So, if you see intensity for any particular component only at a certain location for example, and not for others, then you will be able to say that there is a Gauss texture in the material. Okay. Or for example, in this case brass. So, it will be a brass texture in the material. You can see it in terms of ODF also. Okay, as we saw in case of BCC material. Okay. So, you again have, so this is my phi 2, this is my capital phi. Okay. So, 0 to 90, 0 to 90 and 0 to 90. Okay. So, you have different components and some fibers also. So, you have alpha fiber like this and gamma fiber like this. So, same name as in BCC, but their location in the Euler space is different. Okay. So, and you can also see the different component here. For example, this is a Gauss component here, this is your brass component here, this is S. Okay. Brass, Gauss and cube also. Okay. So, C is your cube component. Okay. So, all the components are also at different location they are situated. Okay. And additionally you have fiber in the Euler space. Okay. And all the angles are also given here. Okay, for different components as well as their HKL UVW values. Now, what will be the effect of alloying element on any texture component is shown here. For example, this is a copper deformed copper. Okay. And initially you have copper components. Okay, which we have already seen in the previous slide. Okay. So, you copper will have this component 112, 111. Okay. So, you will have copper component, intense copper component, but as we keep adding zinc, okay, and we are trying to make a brass material which is an alloying element of copper and zinc. Okay, you can see that what is the effect on the pole figure and also texture. Okay, so, it is getting concentrated and giving rise to a brass component, which is what we discussed in the previous slide. This is my brass component. Okay. So, that is becoming strong with the addition of zinc in the material. Okay. And the reason for this change is that when you add zinc, the sticking fault energy changes. Okay. And because of that the texture component changes, because you will have a different deformation mechanism. Okay. So, there will be also effect of alloying element on the texture component. Okay. So, we have seen that there can be different types of texture component in different material with different crystal structure. Okay. For example, BCC and FCC, and we have seen the exact location of different texture component in these two different types of material. Okay. And we have also seen that there will be effect of alloying element also on the development of texture as a function of processing. Okay. So, this was a short lecture to give you an overview of different type of texture components which can be there in the PCC or FCC materials. Okay. So, with that thank you for your attention.